Alright, in this video we'll be going over the 2009 AP Calculus exam. Alright, so the first question is a nice easy warm-up, and if you've taken physics, this should be an absolute cakewalk. So we have Karen riding her bicycle from home to school, starting at 0, ending with 12, and her velocity is shown here. At part A, we want to find the acceleration of that bicycle at time t equals 7.5. Okay, so let's identify 7.5 on the graph. It's in between 7 and 8, that's like right here. Okay, now also we want to say, okay, so we want to find the acceleration. The key thing to realize here is that the acceleration is the slope of the velocity. Okay, so if we want to find the acceleration at 7.5, we should look at the slope of the velocity at 7.5. That's going to be the slope of this downward segment here. Okay, what's that going to be? Well, let's see here. Our height changes from 0.3 to 0.2, so it goes down by 0.1. So change in y is negative 0.1. I'll just read it here actually. This is change in y over change in x, right? It's going to be negative 0.1 over, and then our x goes from 7 to 8, so it goes forward by 1. Okay? So it's going to give us negative 0.1. Now for the units, okay? So notice it's y over x, right? So the units for this are going to be the units for y over the units for x. So on our y-axis, we have our velocity. And the units for velocity is miles per minute. So it's going to be on the top. It's mi, I guess. Mi for miles. So miles per minute. And then on the bottom, we have the t, which is measured in minutes again, right? So our change in y is in miles per minute. Our change in x is in minutes, okay? So the most commonly way of writing this, we don't write it as miles per minute, but more often than not, you'll see it as miles per minute squared. Okay, so 2-point question, 1 point for the answer and 1 point for the units. Okay? Okay. Part B. Using correct units, explain the meaning of this and find the value of that as well. Okay? So the key thing to notice here is that there are absolute values around the velocity, right? If they just asked you for the integral from 0 to 12 of the plane velocity, this would actually give you the displacement. That's going to tell you, you started at your house, you ended at the school. What is the straight line distance between the school and the house? But we want to figure out the integral from 0 to 12 of the absolute value of the velocity with respect to time, and that's going to give you the distance. Okay, the distance. And what that means is if you go forward a bit, then you stop and you turn around and you go back and you go forward and you do all crazy stuff. This is going to tell you the total distance that you traveled. If you had like a measuring device and it measured how far you walked, that's what this is going to give you. So they're asking you, what does it mean? Well, it's going to be the distance that Karen travels between 0 and 12. Now to find the value of it, all we got to do is find the area under this graph. Remember, the integral is the area under the graph between 0 and 12. Okay, so let's do that. This first section here is going to be 1/2 times 2 times 0.2, okay? And then this next section here is going to be also 1/2 times 2 times 0.2. And notice that these are both positive because even though this one's under the axis, it's the absolute value that we're interested in, okay? Now for this next section, honestly, the easiest way for me to do this is just count the squares here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So this 11 here, we can literally just count the squares and say it's 11. And since each square is going to be 1 times 0.1, which is 0.1, 11 squares are going to be 1.1. Okay? And then, let's see, next. Oh, it's an awful color. I can barely see it. Let's do this. Okay, so next we can find this guy. So this is basically, if you can imagine taking this top part of the triangle and shifting it down here, you'd get a full block. So it's going to be another 0.1. You can also think about it as using the area formula for the triangle with a base of 1 and a height of 0.2, and you'll get the same answer. Okay? And then what's next? We got this. Okay, I'll do it in black, I guess. So black. Here we have this part here. That's going to be, I'll do the writing in white, of course. It's going to be here, let's see, it's going to be 1/2 times 1 times 0.1, and then finally, I'm kind of running out of colors here. Let's do, I'll reuse the red one. We have this guy here. We have this tiny bit. That's going to be 1/2 times 1 times 0.1. Okay? And I actually realized I made a mistake here. I apologize. This should be 3, not 1. My bad. Okay? So, all you gotta do, take all of these things, put these in your calculator, and you will get a total value of 1.8. And we want to know the distance that she traveled, so that's going to be in miles, right? Because remember, our units for displacement were, or our units for distance were, our units for velocity were miles per minute. So her distance is going to be measured in miles. Okay, so 1.8 miles. There's your answer. And this was a 2-point question. 1 point for the explanation that this is the distance from 0 to 12, and this second point for your answer. Part C. Shortly after leaving home, Karen realized that she left her calculus homework at home. I've totally never done that before. And she returns to get it. At what time does she turn around to go back home? Give a reason for your answer. Okay, so it's a very likely scenario, you might need to do this any day, so let's figure out what's going on here. So we want to figure out, when does she turn around to go home, okay? So she's walking to school, right? She's going to school. So here's the school. She's walking to school, she's going this way, and then she stops, she's like, oh wait, I gotta turn around, I'm gonna go back this way to go home. Right? So she's walking this way at first, she's going and then she turns around, she's like, oh wait, I gotta go back home. So she turns around and goes back home, right? So here, in this part where she's going to school, her velocity is positive, right? Because she's moving in the right direction. But here, she stops, she turns around, she goes back, here the velocity is negative, right? So at the time she stops to turn around and go back home, her velocity is going to be 0, and she just went from a positive velocity to 0 to a negative velocity, right? So we need to figure out where on this graph does the velocity go from positive to 0 to negative. And we can see, just looking at it, that at t equals 2, right here, her velocity goes from positive, which is above the t-axis, to 0, to below the t-axis, right? So here, she stops and turns back and goes home. Okay? So the answer to that is t equals 2. And also an explanation, you can say because that is where the velocity switches from positive to negative. This was a 1-point question. 1 point for the correct, actually no. Sorry, it's a 2-point question. 1 point for the correct answer, 1 point for the explanation. Alright, part D. Larry also rides his bicycle along a straight road from home to school in 12 minutes. His velocity is modeled by the function w given by that, where w and t is in miles per minute for t between 0 and 12. Who lives closer to school, Karen or Larry? Show the work that leads to your answer. Okay, so this one was very, very tricky because you really need to know the answer between distance and displacement to get this right. Okay, we want to know displacement here, not distance. Okay, so if this is the school, right, we're going back to my high quality drawings. So this is our home, and this is our school. Remember, earlier on, we calculated that the integral from 0 to 12 of the absolute value of velocity, this is 1.8 miles, right? But that is not the distance between the house and the school, okay? This is the distance that she walked. So it's the distance that she walked here, and then she turned around, and then she went to school, right? So we're counting this distance too when we're finding her total distance, okay? If we want to find just how far the school and the house are from each other, we have to do a different integral, and that's going to be the integral from 0 to 12 of just the velocity, okay, no absolute value. And that's going to give you just the plain displacement between the house and the school. So if you just walked from here all the way to there, how far is that distance, okay? So this is going to be Karen's distance, okay? And you do a very similar thing to what you did in part B, but these two would cancel out, right? So you'd subtract 0.4, because this is 0.2 and this is 0.2, these would cancel out. So you'd subtract 0.4, and your final answer would be 1.4 miles. Okay? And then we need to find Larry's distance, right? My friend Larry. And to find Larry's distance, we have to take the integral from 0 to 12 of his velocity function. Oh, what's his velocity function? It's w of t. Yeah, w of t. If you take the integral of this from 0 to 12, you will, obviously, you just put this in the calculator and you evaluate the integral, you will get 1.6 miles. Okay, so it's clear who lives closer to school. Well, Karen lives closer to school because her distance is less than Larry's. Poor Larry. So the answer to the question is Kaylee lives closer to school because 1.6 is greater than 1.4. Alright? This was a 3-point question. 1 point for Larry's integral, 1 point for Larry's answer, and 1 point for Karen's integral, or 1 point for Karen's answer, and the correct explanation that Karen lives closer to school because her distance is less. That concludes the first question. Question number 2. The rate at which people enter an auditorium for a rock concert is modeled by the function r, given by r of t is equal to this, for t between 0 and 2. Dude, I love rock concerts. I go to rock concerts like every day. It's pretty nice. R of t is measured in people per hour. No one is in the auditorium at t equals 0. The doors close and the concert begins at time t equals 2. So everyone who entered the auditorium entered between 0 and 2. Okay? In part A, we're asked, how many people are in the auditorium when the concert begins? So what we've got to do here is we've got to say, okay, since I know all the people who entered between 0 and 2, I can take my rate of change function, which tells me how many people enter at a specific time, and I can add that up for all the different values of t between 0 and 2. Alright, so what we're going to do is we're just going to integrate it between 0 and 2, add up all the different values. So 1380 t squared minus 675 t cubed dt. This is going to equal, if you put this in your calculator, 980 people. Right? Nothing crazy there. I just integrated from 0 to 2 of r of t dt, right? In case it wasn't clear. So that's what I did. This is a 2-point question, 1 point for the integral, 1 point for the answer. Okay, find the time when the rate at which people enter the auditorium is a maximum, justify your answer. Okay, I'm sure you've done this problem a bunch of times before. We're just going to follow standard protocol, right? Find the maximum. Take the function that you want to find the maximum of, take its derivative, set it equal to 0. You know, I'm sure you know this, right? So let's find the derivative. We have r prime of t. Okay, using the power rule, we'll get 2,760 t minus 2,025 t squared. Okay, now we've got to set this equal to 0, but we've got to do it on a new line. So I'll take this and set it equal to 0. Okay, and then we have to solve this for t, so I'll factor out a t. Equals 0. So now we have two options. Either t equals 0 or t equals whatever this is going to give us. So if we solve that, we subtract 2760 and divide by 2025, we get t is equal to 2760 over 2025. Okay, now if you put this in your calculator, you'll get a value that's about 1.363, but here we want to be exact. Okay, so what we're going to do is we're going to take this and we're going to store it in our calculator. Okay, so I'm going to set this equal to a. Okay, I'm going to just explicitly say that you're going to set this equal to a variable a. So whenever I want to use this time in the future, I'm not going to write the whole thing out. I'm just going to use the word a, the letter a. Okay, so now we have our options, right? We have, if we want to find out where is the maximum, we have two different places where the maximum can come from. We have the endpoints or we have critical points, right? So our critical points are going to be t equals 0 and t equals a. So we have t equals 0 and t equals a. And we have our endpoints, which are t equals 0, which I already wrote, and t equals 2. Okay, so we have our endpoints, and our critical points, okay? So one of these three is our maximum. So all we got to do is we're going to find R of 0, R of A, and R of 2 in your calculator, and you'll see whichever one is biggest, that's your answer, right? So R of 0 is 0, because there's no one when the constant begins. R of 2 is 120, just plug in 2. And then R of A is going to be 854.527. Okay? So that is the different rounds, and obviously it's clear to hear that R of A is the biggest of the bunch. So the maximum rate at which people are entering is at t equals 1.363, approximately equal to, so t equals A, right? That's the answer. I think that's what they asked us for. They wanted to find the time. And for the justification, this is your justification. You're trying all the different values, okay? So that's the end of question 2. This was a 2-point question, 1 point for the answer, 1 point for your justification. Okay, question part C. We have the total wait time is, for all people in the auditorium, is adding the time each person waits, starting at the time they enter and ending when the concert begins. The function W is the total wait time for all the people who enter before time t. The derivative of W is given by this. Find W of 2 minus W of 1, the total wait time for those who have entered after t equals 1. Okay, so the important thing to realize here is if you want to integrate a function, okay, so this is the fundamental theorem of calculus. If you want to integrate a function between a and b, and it's f prime of x dx, this is just going to equal f of b minus f of a. Okay, so if we want to find w of 2 minus w of 1, we have to integrate from 1 to 2 w prime of t. And that's going to equal w of 2 minus w of 1, right? You can kind of match the different pieces there. So I'm going to erase this because we want to focus on this guy here. Okay? Let me just real quick, let me just copy paste and bring it up to the top. Okay, so how do we evaluate this guy, right? We know what w prime of t is. It's 2 minus t times r of t. Well, we know what r of t is. It's this guy. So we just got to plug those in, right? So w prime of t is going to be 2 minus t times r of t. Well, r of t is 1380 t squared minus 675 t cubed dt. Okay? You take this guy, you evaluate it in your calculator, you will get 387.5 hours. Okay? That's your answer. And yeah, so this was a 2-point question, 1 point for the integral, 1 point for the answer. This was really just an application of the fundamental theorem of calculus. Okay, so part D, on average, how long does a person wait in the auditorium for the concert to begin? Consider all people who enter the auditorium after the doors open and use the model for total wait time for part C. Okay, so if you want to think about the average wait time, right, for a person, the average wait time is going to be the total wait time divided by the number of people, right? That should make intuitive sense, okay? And we can find the total wait time by integrating from 0 to 2 w prime of t, right? And then we can find the total number of people from remembering from part A that there are 980 people in the auditorium. Okay? So this is going to get you the average wait time. Alright? So if you just evaluate integral from 0 to 2 of 2 minus t times r of t dt, and you divide that by 980, you will get your correct answer of 0.776 hours. Okay? And obviously, it's in hours because our time has been always measured in hours. Okay? That was a 2-point question again. 1 point for the setup and 1 point for the answer. Third question. Mighty Cable Company manufactures cable that sells for $120 per meter. I just want to say, I was about to start a cable company, and I was going to name it Mighty Cable Company, so AP kind of took my thing, man. It's not cool. Whatever. For a cable of fixed length, the cost of producing a portion of the cable varies with its distance from the beginning of the cable. Mighty reports that the cost to produce a portion of cable that is X meters from the beginning of the table is 6 root X dollars per meter. Note, profit is defined to be the difference between the amount of money received by the company for selling the cable and the company's cost of producing the cable. Part A, we need to find the company's profit on the sale of a 25-meter cable. Okay, so we need to take the difference between the amount received. So they said profit is the difference between the amount they made, so the amount of money they received, amount received minus the amount they spent. Okay, so how much did they receive? Well, if it's a 25-meter cable and they sell $120 per meter, that's going to be 120 times $25. I apologize if you can hear any sound. And then the amount that they spent, well, let's see. Okay, so we know that the portion of a cable that's X meters is 6 squared of X dollars per meter. And if we want to find the total cost of producing the entire cable, that's going to be the integral from 0 to 25 of the cost, which is 6 squared of X dx. Okay? So if you were to evaluate this in your calculator, you would get that the profit is $2,500. That concludes part A. This is a 2-point question, 1 point for the setup, 1 point for the answer. Part B. Using correct units, explain the meaning of the integral from 25 to 30 of 6 squared of X dx in the context of this problem. Notice I haven't erased this. That's for a specific reason. We'll get to that in a minute. Okay, so we want to figure out what this means. Okay, so we know that if we want to find the cost of a 25-meter cable, that's going to be the integral from 0 to 25 of 6 squared of X dx. That's cost of 25 meters. And we want to find the cost of a 30-meter cable, that's going to be the integral from 0 to 30 of 6 squared of X dx, right? Now the difference, I'll label that's cost of 30 meters, okay? Now the difference between these two is just that this is 25 and this is 30, right? So the difference between these two is the gap from 25 to 30. So the difference is going to be the integral from 25 to 30 of 6 squared of X dx. You can kind of think of it like a timeline, right? So like a 0 here, and then here's 25, here's 30. This first one goes from 0 to 25, the second one goes from 0 to 30, and the difference between these two is this extra distance. That's the 25 to 30, okay? And then they're asking, well, what does this mean? Well, it's simply the difference in cost between a 25-meter cable and a 30-meter cable, okay? So for your answer, you'd say, okay, well, the integral represents the difference in cost, in dollars, of course, of producing a 35-meter cable and producing a 30-meter cable and a 25-meter cable. That was a simple 1-point question, okay? And now we get to part C, which is probably the easiest question in any AP test ever, period. Write an expression involving an integral that represents Mighty's profit on the sale of a cable that is K meters long. Okay, so we know how to find the profit on a 25-meter cable. Now, to find the profit on a K meter cable, we just take this, and whenever we see 25, we replace it with K. That's it. So I can, I'm just going to copy paste it just to show how funny I think this is. We'll take this. Okay, we'll take this. We will literally just now replace the 25s maybe a bit bigger eraser than that. Erase the 25s, 25 here, 25 there. We'll replace those with k, and that is the end of the problem right there. That's 2 points. 1 point for the integral itself, and 1 point for the entire expression. Okay? That was the extremely grueling and very, very difficult part C. Part D, find the maximum profit that Mighty could earn on the sale of one cable. Justify your answer. Okay, now we can do something a bit more AP level, a bit more difficult. Okay? So if let's define some function. It's called P, okay? We'll say P of K equals profit. Okay? If we want the profit to be maximum, then that would mean that P prime of K is going to equal 0, right? So let's figure out what P of K is. So from the beginning, from part C, we can say that P of K is going to be 120K minus the integral from 0 to K of 6 square root of x dx, right? Now to find P prime of K, we'll take the derivative of this. So 120K will become 120, and this will become the derivative with respect to K of the integral from 0 to K of 6 square root of x dx. Now, if you're familiar with how to take this derivative, it's just kind of like the integral and the derivative, they sort of kind of cancel out. I'm sure it's not the most mathematically accurate way to represent this, but I kind of think of it as just these cancel out, and you just replace the x with the k, and you call it a day. 6 square root of x. Okay? 6 square root of, not x, k. Okay? So that's P prime of K, and now we got to set this equal to 0, right? So on a new line, 120 minus 6 square root of K equals 0. Solve this. We can subtract 120 divided by 6. We get square root of K is equal to 20. So that would mean that K is going to equal 400, right? That's the length of the cable, by the way. So if we were to do a number line to quickly test our assumption, put 400 on here, and this is P prime of K. If we put a number greater than 400 here, we'll be subtracting more, so we'll get a negative answer. And if you put a smaller number, we'll get a positive answer. So you can think about it, it's going up, it stops, it goes down. That's the maximum right there. So we are good, okay? So the maximum profit, therefore, is P of 400. What's P of 400? You plug 400 into the equation up here for P of K. You evaluate that in your calculator, and you get, well, I just read it out actually real quick. 120 times 400 minus the integral from 0 to 400 of the stuff inside, which is 6 squared x dx. And this comes out to be 16 grand, 16K, 16,000. Okay? That's a good profit on one cable. Dang. So anyways, this was a 4-point question, right? 1 point for saying that P prime of K is equal to 0. 1 point for finding the appropriate K value. 1 point for justifying that's the right K value. And 1 point for finding the correct profit that goes along with that K value. That concludes the third question. Question 4. Let R be the region in the first quadrant enclosed by the graphs of y equals 2x and y equals x squared, shown in the figure above. Part A asks us to find the area of R, okay? So we want to find the area. The first thing we want to do is we want to find this radius, I'll call it, okay? It's distance between these two equations that are making up our curve, and so we need to subtract that pretty much, right? And since this one is on the top and this one is on the bottom, to find this distance, we'll take the top and we'll subtract the bottom, right? We'll take this y value from here down to here, and we'll subtract this y value that goes from here down to here, and we'll be left with this section in between, right? So this top curve, this is y equals 2x. The bottom curve, this is y equals x squared, right, from here. 2x is the straight line. And if we want to find the difference between these two, like I said, we have to subtract this, where we do top minus bottom. Since y equals 2x is on top, and y equals x squared is on the bottom, this radius is going to be 2x minus x squared. Okay? Now what we're going to do, so we have to integrate this from this x-coordinate to this x-coordinate. So where we start to where we end, right? We're starting at 0, and we're ending at 2, right? 2, 4. So we go from x equals 0 to x equals 2, and we're integrating 2x minus x squared dx, okay? So for example, so each value of 2x minus x squared for like each different x value between 0 and 2, that's going to give you like this line and this line and this line and this line and this line. And we're just adding up all of like an infinite number of those lines between 0 and 2, and all those lines added up together will get us the entire value of the shaded region R, okay? That's the idea here. So we integrate this, remember this is the second half of the test, so we can't use a calculator, so if we do this by hand, we'll integrate this real quick. Integral of 2x is going to be 2x squared over 2, which is just x squared, and the integral of negative x squared is negative x cubed over 3. Remember, add 1 and divide by that thing. And then since this is a definite integral, we don't need to plus c, but we go from 0 to 2. We plug this in, we get 4 minus 8/3. And the 0 wouldn't really do anything meaningful. So we don't have to plug that in, and that is our final answer for this area, okay? This is a 3-point question, 1 point for this integrand, 1 point for correctly taking the antiderivative, and 1 point for the correct final answer. Part B, the region R is the base of a solid. For the solid at each x, the cross-section perpendicular to the x-axis has the area A of x equals sine of pi over 2x. Find the volume of the solid. Okay, so what we're going to do for this kind of question is they're actually giving us the area, so they made this question a lot easier. All we got to do is we're going to take the area and we integrate it from the start to the end. Okay, so they give us the area. All we have to do for part B is integrate this from start to end, so from 0 to 2. That's going to be sine of pi over 2x. Right, and the intuition here is that at each x value, the sine of pi over 2x is giving us kind of like the height, if you can imagine like a third axis here, like coming out of the screen, right? It's going to give you like the height at each point, and we're adding up all the heights at all the different points to get us the volume of the 3D shape that we generated. Okay, so this is that, and again we need to do this by hand. You do u substitution here where u is equal to u is equal to pi over 2x. This should be something you can do in your head, but if you don't know if you're not comfortable doing it yet, by all means do the u substitution. It'll take a little bit longer, but you should still get the same answer. Remember, the integral of sine of x is negative cosine of x, so we'll get negative 2 over pi cosine of x from 0 to 2, which is equal to, cosine of x. My bad. Cosine of pi x over 2, right? Pi over 2x. So negative 2 over pi. If you plug in 2 into here, you'll get cosine of pi, which is going to be negative 1. Then we'll subtract. Plug in 0 in here, you'll get cosine of 0, which is 1. So this is going to be negative 2 over pi times negative 2. The negatives cancel, and we get 4 over pi as our final answer. Okay, this was a 3-point question. 1 point for the integrand, 1 point for the correct antiderivative, and 1 point for the correct final answer. Part C, another solid has the same base R. For this solid, the cross-sections perpendicular to the y-axis are squares. Write but not evaluate an integral expression for the volume of the solid. Okay, so the key word in this question is y-axis. Okay, because so far, and in a lot of these problems actually, we're dealing with something that's perpendicular to the x-axis, like we did here. And that's going to be, everything's going to be like y equals something x, y equals something else, like we're doing so far. But now since we're perpendicular to the y-axis, the first thing that we want to do is take everything and turn it in terms of y. So we'll get it like x is a function of y. Okay, so y equals 2x. That's going to become x equals y over 2. Y equals x squared. Well, that's going to become x equals square root of y. Notice we're in the first quadrant here. Thus, there's no plus or minus. Okay, so now let me show you a quick picture of what they're asking for here. So if they're saying the cross sections perpendicular to the y-axis are squares, so if we're perpendicular to the y-axis, we're going this way, right? We're going left to right. And then if these are squares, then we'll have an infinite number of squares, right? And I'm only drawing a couple here, but you can see, like, if you were to do all of these for all of these different heights, they kind of create this 3D shape, and they're asking you for the integral expression to give you the volume of that shape, right? So the important part here, as you can see, is this side of the square, okay? And the side of the square, since you're dealing with everything in terms of y, it's going to be this, whoops, let me draw that a bit better, sorry. It's going to be this y distance from x equals 0 to x equals whatever this is going to be. We already know it's x equals square root of y. And then we're going to subtract this distance from x equals 0 to x equals y over 2. And if we subtract this guy from this guy, we'll have this little bit here, and that's the same as the side of the square, okay? So hopefully you understand the idea behind that. And so what we're going to do is we're going to subtract y over 2 from square root of y. We're subtracting the green, you're subtracting the yellow thing from the green thing. And this is equal to the side of the square, okay, for any given y value. Now, to find the area of the square, we take the side length and we square it, right? So that's exactly what we're going to do here. We're going to take the side length and we're going to square it. And this is going to give us the area of any particular square here, okay? But we don't want the area of one particular square. We want the entire volume of the solid. So what we have to do now is we have to take this and we have to integrate it from the starting bound to the ending bound. And now be careful here, because the bounds are not 0 and 2 anymore, because we're in terms of y, right? So we're going from this y coordinate to this y coordinate. Right, still the same coordinates, 2, 4, but we're looking at the y now, not the x. So we're going from 0 to 4, because these are the bounds for y, okay? So 0 to 4, and it's going to be square root of y minus y over 2 squared dy. And remember, they did not want you to actually integrate this by hand, they just wanted you to solve this. Okay, we're just find the expression, that's all. So there you can see is our final answer. This was a 3-point question, 1 point for the limits, and 1 point for, 2 points for the integrand. That concludes question 1. Question 5. Let f be a function that is twice differentiable for all real numbers. The table above gives values of f for selected points in the closed interval from 2 to 13. In part A, we have to estimate f prime of 4. Show the work that leads to our answer. Okay, so we don't really have that much information about f, right? We don't know anything about what the actual function f looks like. We don't know anything about f prime. We only really know a couple points. We only know these 5 points. So they're asking us to estimate f prime of 4. We really only have this meager information to work with, right? So we don't actually have a function that we can differentiate and plug in x equals 4, so it's not going to work. And we don't have anything at x equals 4. So the best thing we can do is, if we can't actually find the derivative at that one point, and remember, a derivative is actually just nothing but a slope at a certain point, right? It's a slope at one point. If we can't find the slope exactly at 4, well, the closest thing to that is going to be finding the slope between 2 points that are close to 4. Right? That's this next best thing. We're going to use that to estimate the slope at exactly 4. And as you can see in the table, the 2 clear points to use in this approximation are x equals 3 and x equals 5. Okay? So we'll use x equals 3 and x equals 5. We'll find the slope between those 2 points, and that'll be our estimate of f prime of 4. Okay? So that's going to be f of 5 minus f of 3 over 5 minus 3. Well, let's see, f of 5, that's going to be negative 2. F of 3, that's going to be 4. And we're dividing by 5 minus 3 is 2. It's going to be, let's see here, negative 1 minus 2. It's going to be negative 3. Okay? That was a simple 1-point question. Part B, evaluate the definite integral from 2 to 13 of 3 minus 5 f prime of x dx. Show the work that leads to your answer. Okay? So again, we still only have this little information here to work with, so there's obviously not much they can ask us to do here. Okay? So when we're evaluating this integral, in my mind, the clearest way to do this is to split it into two different parts. The first part is going to be the integral from 2 to 13 of just the 3, and then we'll subtract the integral from 2 to 13 of 5f prime of x dx, okay? And we're subtracting because of the negative sign there. And another thing I can do is I can take the 5 and kind of pull it out, okay? So this here part, the first part on the left, is very easy. The integral of 3 is going to be 3x, right? Remember, when there's just a constant, you just add an x. And we're evaluating this from 2 to 13, okay? Minus 5. And then this part, you have to remember the fundamental theorem of calculus, okay? When you're taking the derivative of, when you're taking the integral of a derivative, you can kind of think of it as them just canceling out, okay? So the integral and the derivative are just kind of canceling out, just like a multiplication and division or addition and subtraction cancel out, and you just get f of x. Okay? So this and this, I'm not sure that's the most accurate way to say it, but it makes sense. Okay? So we have this. Now we plug in our numbers. We have 3 times 13 minus 3 times 2. That's this left part here. Minus 5 times, and then we plug in 13 here, so it's going to be f of 13 minus f of 2, okay? And always, it's better to have more parentheses than too little parentheses, because too little parentheses can mess you up, right? So let's see here, f of 13 is going to be 6, okay, that's going to be 6, and f of 2 is going to be 1, okay? So we have 39 minus 6 minus 5 times 6 minus 1, okay? And honestly, we'll just call it there. That's good enough. We plugged in all our numbers. It's numerically equivalent to the final answer, so it's good enough. Okay, this was a 2-point question. 1 point for correctly taking the antiderivative using the fundamental theorem of calculus for this part, and then the second part for the correct final answer. Part C, use the left Riemann sum with subintervals indicated by the data in the table to approximate the integral from 2 to 13 of f of x dx. Show the work that leads to your answer. Okay, so when they talk about subintervals indicated by the table, they're just talking about, this is one subinterval from 2 to 3, and the next one is from 3 to 5, and then from 5 to 8, and 8 to 13, okay? That's what they mean by subintervals. And then, now since they want a left Riemann sum, what that's going to be, is that's going to be, so if we look at the first subinterval, that's between 2 and 3, right? Since the left Riemann sum, we're going to look at the left point, that's 2. We'll take f of 2, okay? And then we'll subtract these two. F of 2 times 3 minus 2. Okay? So that's the first data point. That's the first subinterval, okay? The second subinterval is between 3 and 5, alright? We'll take the left subinterval, or the left data point, that's 3, and then we'll subtract these two. 5 minus 3. Next is between 5 and 8. We'll take f of the left, okay, and then subtract. I think you can see where this is going. The final subinterval is between 8 and 13, so we'll take f of the left one, and then subtract. Okay, we'll just plug in some numbers now, right? We have f of 2 is going to be 1, so we'll have 1 times 1, which is 1, okay? And then f of 3 is going to be 4, right? So this is 4 times 2, which is 8, right? F of 5 is negative 2. So negative 2 times positive 3 is going to be negative 6. Finally, f of 8, you can see here that's positive 3, so it's going to be positive 3 times 5, which is 15, right? And that is your left Riemann sum. If they asked instead for a right Riemann sum, you'd do the exact same thing, but replace the left endpoints with the right endpoints. This was a, see here, this was a, I forgot to note it down beforehand. This was a 2-point question, 1 point for the correct Riemann sum and 1 point for the correct answer. Part D. Suppose f prime of 5 is equal to 3, and f double prime of x is less than 0 for all x in the closed interval from between 5 and 8. use the line tangent to the graph of f at x equals 5 to show that f of 7 is less than 4. And then, similarly, use the secant line for the graph of f on x between 5 and 8 to show that f of 7 is greater than or equal to 4/3. Okay, so honestly, this is a very, very tricky question. I don't think I would have gotten it on an AP exam, and this is probably the kind of question that you skip and come back to later if you have time. But we're here, let's do it, okay? So they did kind of try to give you as many hints as they could. They kind of try to push you in the right direction. So let's see, we have f prime of 5 is equal to 3, and f double prime of x is less than 0 for all x in the closed interval from 5 to 8. So we want to use the line tangent to the graph of f at x equals 5. Okay, so they're probably trying to tell us to write an equation for the tangent line to the graph of f, right? And then plug in x equals 5. So let's do that. Whenever we want a tangent line, we always want to write down the words point and slope. Okay, for a point is going to be 5 comma f of 5. That's the point, and the slope is going to be the slope of the tangent line at that point, which is f prime of 5. Okay, and nicely for us, we have f of 5. In the table, it's -2, like that. And we're also very conveniently given the value of f prime of 5. Okay, so with these two things in mind, we can now come up with the tangent line equation, which is y plus 2 equals 3 times x minus 5. Okay, now they want the line tangent to the graph of f at x equals 5. Okay, and before we get into that, I just want to quickly talk about this f double prime of x is less than 0 part. Okay, so if we were to draw a concave down graph, okay, because when the second derivative is less than 0, that means that the graph is concave down, right? If I were to draw a generic concave down graph, and I were to draw a tangent line, say here, you'll notice that for all the x values, the tangent line is either touching it or above it, right? The tangent line is never below the graph, okay? So this means that this approximation, for no matter what x value you plug in, it's always going to be greater than the actual value, okay? So this tells us that at, for example, x equals 7, because that's the data point we're interested in, we know that the tangent line is going to be greater or equal to f of 7, okay? Now all we got to do is we've got to figure out what the tangent line is at x equals 7. And that's going to be as simple as taking 7 and plugging it in for x, okay? So y plus 2 equals 3 times 7 minus 5. Y plus 2 equals 7 minus 5 is 2. 2 times 3 is 6. 6. Y equals 4, right? So we can take the 4, plug it in here. So 4 is greater than or equal to f of 7, or if you'd like, f of 7 is less than or equal to 4. Okay? And if you remember from up here, f of 7 is less than or equal to 4 is exactly what they asked us to prove. Okay? Now, if you didn't get the first part, I encourage you to pause the video here and try to get the second part, because it's a very similar idea. Okay, so assuming you've paused and giving it a try, let's look at the second part, right? So we want to use the secant line for the graph of f, where x is between 5 and 8, to show that f of 7 is greater than or equal to 4/3, right? So if I were to draw let me actually just draw a whole new thing. If I have a generic concave graph, and I were to draw a secant line, remember a secant line is a line that connects two different points, right? It's a straight line in between 2 points. So I can use any 2 points I want, let's say here and, I don't know, here. If I were to draw a line connecting those 2 points, notice that the line is always touching or under the graph. The secant line is never over the graph when the graph is concave down, right? And that's going to be the key insight for us to figure out what we're going to do next, okay? So since we're looking at the secant line between 5 and 8, we need to probably figure out an equation for said secant line, right? So if we want to figure out a secant line equation, we need two things. But instead of a point and a slope, This time we need 0.1 and 0.2. Okay? And 0.1 is going to be 5, comma f of 5, and 8, comma f of 8 for 0.2. Right? What's f of 5 and f of 8? Well, we have this convenient table of points given to us, where f of 5 is negative 2 and f of 8 is 3. So this will be 5, comma negative 2, and this will be 8, comma 3. Right? Now, to figure out the actual secant line, remember, go back to algebra 1 forever ago. Remember, you did this in like the very beginning, and you're like, oh wait, I'm probably never going to use this again. Well, guess what? Now it's coming back to haunt you, right? So the first thing, next thing we need to do now is figure out the slope. It's y2 minus y1 over x2 minus x1. So let's say this is our x2 and y2. This is our x1 and y1. That's going to be 3 minus negative root of 3 plus 2 over x2 minus x1. That's going to be 8 minus 5. That's going to be 5 over 3. Okay? That's the slope. And now we need to plug this into the slope-intercept form. And now the thing is, you can choose either of these points to plug in. It's really not going to make a difference. They're going to get the same answer either way. The equation might look initially different, but it's really not going to be any different. Okay, so the answer key actually plugs in 5, negative 2. Just for showing you that it doesn't matter, I'll plug in 8, 3. So we'll get y minus 3 equals 5/3 times x minus 8. Okay. Now remember, we said that the secant line is always below the graph, right? Always below the graph. So if I plug in x equals 7 into here, then the actual value, which is f of 7, should be greater than or equal to the secant line. Okay? So for example, on this thing here, if this is x equals 7, for example, here the actual value of f of 7 is greater than what the tangent line says it's going to be. Okay, and that's what I mean by here when I say f of 7 is greater than or equal to this, oh, sorry, not tangent line up there, secant line. Okay, it's greater than what the secant line said it would be. Alright, so we're going to plug in f of 7 into here. We'll get 7 minus 8, which is negative 1, 5/3, so we'll get y minus 3 equals negative 5/3, and now we add 3 both sides, so y is equal to 5 over 3 plus 3, which is 5 over 3 plus 9, oh sorry, negative 5/3, negative 5 over 3 plus 9 over 3, which is 9 minus 5, which is 4 over 3, right? So secant line gives us 4/3, we know is actually greater than or equal to that, so we can say that f of 7 is greater than or equal to 4/3. Okay, so in terms of points, this was a 4-point question. 1 point for correctly getting the tangent line equation, 1 point for correctly proving that f of 7 is less than or equal to 4. The third point for the secant line equation, which is right here, and the fourth point for correctly getting the value of correctly proving that f of 7 is greater than or equal to 4/3. Like I said, that was a tricky one. Don't worry if you didn't get it. I probably wouldn't have either. And with that, let's move on to the final question in this set. The derivative of a function f is defined by this piecewise function. The graph shown here has x-intercepts at negative 2 and 3 ln 5/3. The graph of g from negative 4 to 0 is a semicircle, and f of 0 equals 5. Part A. From negative 4 to 4, find all values of x at which the graph of f has a point of inflection and justify your answer. Okay? So how do we do this? Well, we don't know anything about f, right? Pretty much every single piece of information they've given us, except for the fact that f of 0 equals 5, has to do with f prime. We know the equation of f prime, we know the graph of f prime, we know the x-intercepts of f prime, we know what this part of f prime looks like, we know what it is, it's a semicircle. The only thing they've given us about f is that f of 0 equals 5. So if you want to figure out where f has a point of inflection, we're going to have to try to figure out a way to connect f and f prime, because all we know is about f prime. So the key insight there is that if f has an inflection point, then f prime changes direction. And what I mean by changes direction is it goes from increasing to decreasing, or decreasing to increasing, okay? So where did that happen? Well, if we look at f prime of x, you can see here it goes down, it's decreasing, and then it changes direction, goes up, and then here at 0, it changes direction again, and it goes down. So there are 2 points where it changes direction. It goes down, up, and down. So it changes direction here at -2, and it changes direction here at 0. So f prime changes direction at x equals -2 and x equals 0. For your justification, you're going to say at x equals -2, f prime switches from decreasing to increasing, and at x equals 0, it switches from decreasing to increasing. And as we've shown here, when f prime switches direction, f has an inflection point. So these are the 2 x values where f has an inflection point. This was a 2-point question, 1 point for the answer, 1 point for the justification. Part B, find f of -4 and f of 4. So this question is actually a little bit trickier than it initially seems, okay? So the key insight that we're going to use to figure out what f of -4 is we need to figure out some kind of equation that has f of -4 in it that also connects to f prime, okay? So we're going to use the fact that f of 0 equals 5. We're going to use the fact that we know like everything about f prime of x, and we're going to use the fact that we want to find f of -4. We're going to use those tidbits, we're going to put those all together, and we're going to come up with the equation that the definite integral from -4 to 0 of f prime of x dx equals f of 0 minus f of -4. Okay, so what do we have here? Let's look at this a bit more closely. We have the application of the fundamental theorem of calculus, right? That's really all this is, where we're taking the integral of a derivative and they kind of cancel out, and we just get f of 0 minus f of -4, right? So what do we do now? Well, we know what f of 0 is. We can figure this out because, like I said, we know everything about f prime of x, so then that'll allow us to figure out f of -4, okay? And now the second key thing to realize here is that since we're going from -4 to 0, well, since we're going from -4 to 0, -4 to 0, f prime of x is just g of x. So I can replace f prime of x with g of x, because that's what we're dealing with from -4 to 0. That's this part. We're not even looking at this positive part, only here. Right? So I can solve this for f of -4, and I'll get f of -4 equals f of 0 minus the integral from -4 to 0 of g of x dx. Okay, what is f of 0? Well, f of 0 is 5. What is this? Well, that's going to take another second, right? So this is going to be the area under g of x above the x-axis. And in the picture, that's going to look something like this, right? Again, we're only going from -4 to 0, right? So how do we figure out this? Well, the easiest way to think about it is through a picture, right? If we have, if we want to figure out the area of this weird skate ramp thing, for me, that looks like it's equal to a rectangle where you cut a semicircle out of it, right? If you take this entire rectangle and you cut the semicircle out of it, you'll get the exact shape that we want to find the area of, right? So we'll find the area of this, and we'll get the area of this. The area of the rectangle is this, is 1, 2, 3, 4 times 1, 2, it's going to be 8. And the area of the semicircle, well, that's going to be, let's see here, it's a semicircle with a radius of 2, right, 1, 2. So the area of the semicircle is going to be 1/2 pi times 2 squared, which is 2 pi. So 8 minus 2 pi, right? This kind of fresh, tall walker, mind your decisions-esque drawing using the image is actually really helpful to visualize these kind of things that they often ask you about in AP Calculus, right? So we have this, we'll put that in here. We're subtracting 8 minus 2 pi, this 8 minus 2 pi, and then we solve that for f of -4. It's going to get us 2 pi, 5 minus 8 is negative 3. So 2 pi minus 3. Okay? And then f of 4 is going to be pretty similar to this, right? So for f of 4, we're going to use the fact that, well, we're going to use pretty much the exact same thing we did before, but instead of the integral going from negative 4 to 0, it's going to go from 0 to 4. 0 to 4 of f prime of x dx equals f of 4 minus f of 0, okay? And now, remember, we're not going to be using g of x anymore, because from 0 to 4, f prime of x is not g of x anymore. F prime of x is this equation here, 5e to the negative x over 3 minus 3. It's 5e to the negative x over 3 minus 3 dx equals f of 4 minus f of 0. We can solve this for f of 4 equals, so if you add that together, you get 5 plus the integral okay. And unfortunately, we can't just throw this in our calculator because, we can't just throw this in our calculator because this is question 6 and we aren't allowed to use a calculator. Okay, so, what do? Well, we just integrate this by hand. Okay, this is going to be a really simple integral to evaluate. It's going to be a u substitution where u is equal to x over 3, negative x over 3. You should be able to do this in your head. If you can't, there's no worries. This is equal to 5 plus, okay, so this is going to be 5 times negative 3 times e to the negative x over 3, minus 3x. So the integral of 5x to the negative x, 5e to the negative x over 3 is this part, and then the integral of negative 3 is this part, and this part is going from 0 to 4. The entire thing is going from 0 to 4, right? And this is equivalent to f of 4. So all we've got to do is plug in our numbers, and we're home free. 5 plus, all right, so 5 negative 3, it's negative 15. If we plug in 4, we'll get e to the negative 4/3, right? If we plug in 4 here, we'll get minus 3 times 4, which is 12, right? And then now I'm going to put the second set of parentheses in here just to close this set off. And then we're going to subtract. Plug in 0, we'll get 5 times negative 3 times e to the 0. Remember, e to the 0 is 1, so we'll be subtracting 5 times negative 3 times 1. So we'll be subtracting negative 15. Okay, so 5 times negative 3 is negative 15, times 1 is negative 15 still. And then minus 0 is not going to do anything. Okay, so is that, I'm just going to simplify just a tad. It's going to give us 5. It's really just for making it look a tiny bit nicer. Negative 15 e to the negative 4/3 minus 12 plus 15, and I think I'll call that a day. Okay, 5 plus here minus 12 plus 15. Okay, that is equal to f of 4. All right, and in terms of points, this of course was quite a long problem, so it's going to give us quite a bit of points. This is going to give us 5 points. All right, so point 1 comes from this part of your integral for f of negative 4. Point 2 comes from 2 pi minus 3. Point 3 comes from this part of your integral for f of 4. Point 4 comes from actually integrating it correctly, and point 5 comes from this slightly longer expression for f of 4. Part C. For negative 4 is less than or equal to x is less than or equal to 4, find the value of x at which f has an absolute maximum. Justify your answer, okay? So again, this is kind of the thing where we don't really have anything about f, so we have to try to convert what we know about f to what we know about f prime, like we did in part A. Okay, so we know that if we're looking at the absolute maximum of f, we should be looking at the sign of f prime, so whether it's positive or negative, okay? And if we're looking at the sign of f prime, we'll see that from negative 4 all the way up to this point, which is 3 ln 5 over 3, because that's where it has an x-intercept, right? So we know that from here to here, it's either 0 or positive, right? So what I'm going to say is I'm going to say that f prime of x is greater than 0 for negative 4 is less than x is less than 2, and negative, and 2, that should be negative 2, right? Yeah, negative 2 is less than x is less than, let's over a bit, scoot, thank you, okay, it's less than 3 ln 5 thirds, right? Notice the reason I wrote it this way is just to exclude x equals negative 2, because at that point it's not greater than 0, it's equal to 0, right? So it's basically from negative 4 to this point, but not x equals negative 2, okay? And so because this is true, well, that tells us that since f prime of x is greater than 0 for this point, this tells us that f prime of x, or f of x is increasing on these values, right? Because remember, f is increasing, that means f prime is positive, but it's got a positive slope, it's going up. Okay? And then we can make a similar argument for anywhere after that. So from x equals 3 ln 5 over 3 to 4, f prime of x is less than 0, right? What does that tell us? Well, that tells us that f of x is decreasing on those points. It's decreasing because the slope is negative, it's sloping down, right? The tangent line is going down. Okay? Tells us it's going down, it's decreasing. So what do we know? Well, we know it switched from increasing to decreasing, right? If I were to draw a graph, it looks something like this. And now, just looking at this, it's pretty obvious where the absolute maximum is, right? It's going to be at the top of that hill. It's going to be the x value where it switches from going up to going down. We don't even really need to test any of the other points. It's pretty obviously at this one point at the top there of the hill. So it's going to switch, or it's going to be maximum where f prime switches from positive to negative. And that's at this point right here at x equals 3 ln 5 over 3. Okay, so I'm not going to write this out, I'm just going to say it out loud. Let's say something along the lines of x has a absolute maximum at x equals 3 ln 5 over 3 because f prime of x is greater than 0 for negative 4 is less than x is less than negative 2, and negative 2 is less than x is less than the 3 ln 5 over 3, and f prime of x is less than 0 for 3 ln 5 over 3 is less than x is less than negative 4. Basically, in a condensed version, f prime of x is less than 0 in this part and greater than 0. No, other way around. It's greater than 0 in this part, less than 0 in this part. That means it has an absolute maximum at the point where it switches. Okay? That was the end of question 6. This was a 2-point question. 1 point for the answer, 1 point for the justification. Yeah, so that concludes question 6. That concludes this review video for 2009 AP Calculus AB. I hope you found this helpful, and I will see you in the next one. Goodbye for now.